Hello everyone. In this video, we're gonna talk about linear second order differential equation or linear second ODE. Okay, the two kinds of linear second ODE. The first one that we're gonna talk about is the homogeneous differential equation, and the second one is non-homogeneous equation. Okay, first we have to know what is linear second ODE and what is homogeneous and non-homogeneous. Okay, let's take a look at the definition and the theory. Okay, when we have a function ax, a is a function of x, y double prime plus bx y prime plus cx y equal to fx, ax, bx, cx, fx is a function that contains of x only. Okay, we can rearrange into this star equation, which is y double prime plus bx over ax times y prime plus cx over ax times y equal to function of x over ax, or in other form, which is y double prime plus px y prime plus qx times y equal to jx. And this is a kind of linear second order differential equation. Okay, for the homogeneous, that means this one gx, this form is equal to 0. Okay, if gx is not equal to 0, then it's going to be non-homogeneous equation. Okay, and for the homogeneous and non-homogeneous equation, we have a method that we can use to solve this kind of function. Okay, let's take a look. Now take a look at the homogeneous linear equation with constant coefficient. This is more simple for the linear second ODE, which is the term gx equal to 0, which means it's a homogeneous linear equation. Okay, for the linear equation, it's in this form, which is ay double prime plus by prime plus cy equal to 0, and a is not equal to 0, and b and c are real numbers. Okay, these are examples of linear second ODE. For example, like y double prime plus 3y prime plus 4y equal to 0. So because gx equal to 0 here, so it's homogeneous equation. And this one is y double prime minus 5y prime plus 2y equal to 0. Okay, and 5y double prime plus 4y equal to 0. All these are non-homogeneous linear second order. Okay, to solve this kind of equation, we have to find a function that when we derivative and substitute it into the equation, then it gives zeros for the answers. You know, that means that function is equal to this one, which is e to the rx is gonna be the answers of this non-homogeneous linear equation. Okay, now let's take a look how this kind of function is going to be the answer in the next slide. Okay, take a look at this. If we know, or if we think this e to the rx is the answers for the equation, then we have to prove, which is, that means the solution is y equal to e to the rx. And if we do the first derivative, we can get r times e to the rx, and do second derivative of e to the rx, we can get r squared times e to the rx. And then we substitute y prime, and y double prime into the non-homogeneous, to the homogeneous linear equation. Okay, so we substitute it into this, of this into the problem, we get a, and this one is y double prime, which is r squared times e to the rx plus b times y prime, which is e to the rx plus c times y is e to the r is equal to 0. Then we have e to the rx are the same of here, here, and here, so we can take it out. We're going to get e to the rx times a r squared plus br plus c in this parenthesis equal to 0. Because this form e to the rx is not equal to 0, so that means a times r squared plus br plus c is equal to 0. This form is going to be zeros. That means we have to solve what is r. To solve to get the r, we have to use this formula. We call this formula is the characteristics root or auxiliary root. Okay, we know this before. The answer is going to be equal to, r equal to minus b plus minus in the square root of b squared minus 4ac of this over 2a. Okay, so the answer of r is going to be in this form. So we call a r squared plus br plus c is the characteristic or auxiliary equation of a y double prime plus by prime plus cy equal to 0. So then how we gonna solve it? Okay, let's take a look. Next, to get the solution, you have to know this first. For the r, there are three kinds or the three cases. Okay, because when we look at in the square root, which is b squared minus 4ac, in the case that maybe like sometime in this form is the plus sign, which is the positive value, okay, or sometimes it's equal to zeros, or sometimes it's less than zeros or negative value. How's that gonna work? Okay, in the case when we have b squared minus 4ac is more than zeros or positive number, the solution is gonna be y1 equal to e to the r1 x, and y2 equal to e to the r2x, and the final form is y equal to c1 y1 plus c2 y2. c1 and c2, they are a constant, okay, and y1 y2 is here, y1 and y2. Okay, in the case 2, when we have b squared minus 4ac equal to 0, then in this case r1 and r2 are equal, so r1 and r2 equal to minus b over 2a. Okay, so the solution is gonna be y1 equal to e to the minus bx over 2a, and y2 equal x. You don't forget x. Different is here. This one they have x times e to minus bx over 2a, and the final solution is going to be c1 y1 plus c2 y2. And case number 3, when b squared minus 4ac is less than 0, so in this we have imaginary number, which is r equal to lambda plus minus I is imaginary number of mu. Okay, and lambda is equal to minus b over 2a, and the solution, general solution, gonna be e to the lambda x, that's here, times c1 cos mu x plus c2 sin mu x or it's the same, which is C1 times e to the lambda x cos mu x plus C2 e to the lambda x sin x. Okay, so you have to find b square minus 4ac first and see what's the case, case 1, case 2, or case 3. Then use the right solution of y here or here or here. Okay, so now take a look at examples. We have y double prime plus 5y prime plus 6y equal to 0, and this is homogeneous equation because gx here is equal to 0. Okay, and we also have initial condition or IC, which is when x equal to 0, y equal to 0, and when x equal to 0, y prime equal to 1. Okay, that means we have to solve to get c1 and c2, the constant. Okay, to solve the problem, first we have to find the characteristics first. Okay, just just look at this form, and when we have y double prime here, we think this is r squared and y prime is r, so there's no r here, so it's just 1. Okay, and and so in this one, so it's gonna be r squared plus 5r plus 6 equal to 0. So then we have to get into this form, separate this, or you can use the like the characteristic rules that we learned from the previous slide. Okay, or we can, if we can separate it into this form, we can do it. This one is easier. Sometimes we cannot separate into these two characteristics, then you have to find the characteristics root from that. I show you the formula from the previous slide. Okay, in this one, that means we separate here, we get r plus 3 and r plus 2. So that means r is equal to minus 3 and minus 2. So then this going to be going to 0, or in this case, it's case 1. Oops, sorry. And so the solution here is going to be y1 equal to e to the minus 2 here, x, and y2 is e to the minus 3x, and the general solution is c1 e to the minus 2x plus c2 times e to the minus 3x. Since we have initial condition, we have to solve it. So in the case when x equal to 0, you substitute with x equal to 0 here and here, and y equal to 0, so y equal to 0 here. So we get this go to 1 and this one go to 1 too. So that means 0 is equal to c1 plus c2. Okay, this is the first equation. And when we do the first derivative here, get this one, we're gonna get minus 2 c1 e to the minus 2x, and do the first derivative here too. We get 3 minus 3 times c2 e to the minus 3x. Okay, this one equal to 1. Okay, when we substitute with x equal to 0, substitute x here with 0 and 0 here, so 1 equal to, this one equal to 1 and this one equal to 1, so 1 equal to minus 2 c1 minus 3 c2. Okay, and this is a second equation. So then we solve this c1 c2 from this information. Okay, we can just solve something like this. C1 from the first equation, C1 equal to minus C2. Then we substitute C1 in the second equation with minus C2. Okay, so then 1 equal to 2C2 minus 3C2 mean equal to minus C2. Okay, so then C2 equal to minus 1 and then C1 equal to 1. Okay, so the particular solution of YP here is, you substitute C1 and C2, then you get the final answer, which is e to the minus 2x minus e to the minus 3x, and this is the final answer. Okay. Okay, now we look at the non-homogeneous equation. In the previous slides, we talked about the homogeneous equation, which is when gx here equal to 0, and now when the equation is not equal to 0, which is non-homogeneous equation, then we have to find another method to solve this kind of problem. Okay, in terms of non-homogeneous equation, that means that this term gx is not equal to 0. For example, like these three equations. Okay, in the first equation, y double prime plus 3x, y prime plus 2y equal to e to the 2x. The gx here is equal to e to the 2x. So in this case, it's non-homogeneous equation. And this example, 3y double prime plus 4y prime minus 5y equal to x squared plus sine 3x. This x squared plus sine 3x is the gx term, which is non-homogeneous equation. And this one, tan 2x, is the gx, which is and this is non-homogeneous equation. So okay, to solve this kind of problems, so just follow this step. Okay, first consider the homogeneous equation, which is on the left hand side, this side. Okay, and think this term on the left hand side equal to 0. Okay, so for example, in the first problem, first equation, y double prime plus 3x, y prime plus 2y equal to e to the 2x. So in the first step, you just consider on the left hand side, which is y double prime plus 3x, y prime plus 2y equal to 0. And solve this side first. Use the same method as the previous section, the homogeneous equation. Okay, and then on the right hand side, this e to the 2x, we're gonna use undetermined coefficient method to solve it, which is I'm gonna tell you in the next slide. Okay, and the second problem is the same thing. On the left hand side is a homogeneous equation, and this one, the third equation, again, things as this side as a homogeneous equation. Okay, and then on the right hand side, on the gx or the gx term, look at this table. When gx term is not equal to 0, it can be like polynomial equation or exponential equation or sine cosine equation. Then you have to consider this term. Okay, the formula in this table, which is if the gx term is something like polynomial equation, something like this, a0 x to the n plus a1 x to the n minus 1 plus blah 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 until an, just like a is a0, a1, an here is just a constant. Okay, that means this form is polynomial equation. Then you have to predict yp of the gx term. Okay, yp, p is coming from predict, yp is the predict answer or predict solution. Okay, if you see the gx term is polynomial, use this yp. It's just like the guess answers of the gx term. Okay, it's gonna be like x to the s times a0 x to n plus a1 x to the n minus 1 plus blah 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 until an. Okay, and s here, I'm going to tell you now, s is the smallest non-negative integer. Okay, it can be 0, 1, 2, 3 until like you know uh, until you satisfy this form, which is no any product from the multiplications of the predict solution, which is the yp here has the same solution of homogeneous equation. So yc here is from homogeneous equation that you got from the previous slide. So when you look at the homogeneous equation, then look at the yp from this table. If the yp here exactly the same with the yc, then you have to use like a higher value of s. If they are different, then you can use zeros, which is the smallest one. I'm gonna show you like example in the next slide, then you'll see it like more clearer. Okay, and this is the polynomial, and the same thing with exponential. Exponential form is like p is function of x times e to the alpha x, or equal to a0 x to the n plus a1 times x to the n minus 1 plus blah 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 times e to the alpha x. E to the alpha x is telling you that this is the exponential form. Okay, so yp is gonna be x to the s again, it's the same thing, times a0 x to the n plus blah blah blah, which is in this parenthesis is the polynomial equation form, and times e to the alpha x. Okay, and s consider the same thing, which is the smallest positive non-negative integer. Okay, and when p, the gx term, is a sine cosine function, consider this form, which is x to the s times the polynomial form. This is the exponential form too, so you have to put the exponential form. Okay, this is polynomial times exponential times sine cosine. Okay, so this is polynomial times exponential times cos and sine. Okay, whenever you see only sine or cos, just one of these two, but you have for the yp, you have to use both uh, cos and sine in the yp form. Okay, and this one time cos beta x plus x to the s again, the polynomial form, time exponential form, and sine. And don't forget, whenever you see sine or cosine or both, then you have to use both cos and sine on the yp. Okay, and then you have to solve to get the constant a0, a1, a until an from the yp, and you're going to get the final result of the non-homogeneous equation. Okay, I'm going to show you example, then you'll see it better. Now take a look at example of non-homogeneous equation. Here we have y double prime plus y equal to sine x. Here you see the gx is equal to sine x. When you think about sine x, is actually polynomial, which is 1 times sine x. The polynomial form is 1, and sine cosine here is sine x. So when you think about the solution of this problem, first you think about the left hand side first, which is y double prime plus y equal to 0, which is the corresponding homogeneous equation here, and you find the solution of this one. You're gonna get r squared plus 1 equal to 0. Then you solve what is r here. R is equal to plus minus I, which is I is imaginary number. Okay, so the solution here is yc is equal to c1 cos x plus c2 sine x. This is the corresponding homogeneous equation. Okay, now on the ex term, which is the non-homogeneous form, you have to predict yp first, from the table, and the polynomial is 1 as I said, and sine cosine here is sine x. So the yp 1, don't forget 1 here is polynomial, which is the smallest s here, which is s to the zeros. S to 0 is equal to 1, so it's gonna be a, you can use a0 or just a, it's the same thing. A0 cos x, don't forget, plus b, just another constant, let's say b sine x. As I said, whenever we see sine cosine, just 1. For the yp, you have to use both cos and sine. S here in this case is the 0, but when you look at yp in this case, and compare with the yc's from the corresponding homogeneous equation, you see cos, this is cos x plus a constant sine x. This cos x and sine x. See here, it's the same thing. So this is exactly the same solution. So this is wrong. You cannot use this yp. So you have to use another higher value, which is s equal to 1. This is s equal to 1. So when s equal to 1, x to the s is x, times a. It's gonna be ax cos x plus bx sine x to the s, also s here is equal to 1. And then when you compare this yp, it's not the same with the yc. So this is the right way to do. Okay, this is correct way. So then you do the first derivative of this yp. You're going to get this form, and then also do the second derivative of yp here. Just like you're doing the first derivative and then do the second derivative. You do the first derivative, you get here, and you do the second derivative, just like you do this derivative of this form, you're going to get this one. Then after you get yp prime, yp double prime, then substitute into here y double prime plus y. Okay. I'm not going to tell you all the details, just get the idea. So you substitute y double prime plus y, there's no prime here, that's y, plus y equal to sine x. And then you compare the coefficient on the left hand side and the right hand side. Okay, you substitute, this is y double prime, and this is y double prime on this side, which is wrong. Okay, and ax cos x plus bx sine x, this is y equal to sine x here. And then you reduce the form, you get minus 2a sine x plus to be cos x. Then you compare the coefficients on the left and the right hand side. On the right hand side here, there's no cos x, so b here should be 0, right? B here should be 0 because there's no cos x. And sin x here, which is 1 in front, so minus 2a equal to 1 here, so a equal to 1 minus 1. So in the yp, you substitute back, you get a equal to minus 1 over 2, you substitute back to a and b. So yp in this case is minus x over 2 cos x. Then the final solution is going to be y equal to yc from the corresponding homogeneous equation plus yp from the predict solution of the gx term. And this is the yc, and minus 1 over 2x cos x is the yp. And this is the final answer. Okay. If we have initial condition, you have to solve what is C1 and C2, okay, and get the final solution. Now take a look at the second example. Here we have y double prime plus 4y equal to x. X here is the polynomial, right? E to the x and exponential plus x sine 2x. X is polynomial again. Here is sine, cosine. Okay. So first, start with the corresponding homogeneous equation, which is y double prime plus 4y equal to 0. Y double prime is r squared plus 4 here. So in this case, r equal to plus and minus 2i. So that means yc is this is the case number 3. So yc equal to c1 cos 2x plus c2 sin 2x. Now think about on the right hand side, the gx term. You can do one by one term, or you can do both. But when you do these two terms together, it's gonna get more complicated and long. You can do a little mistakes like the side, the plus side, or the minus side. So what I suggest is you should do like one by one term. So the gx term, the two terms here, x e to the x, one term, and x sine to x, another term. Okay, in the first term, you have to use that table to predict yp. So the polynomial here is x. So start with x to power 1, x power 1 here. So the polynomial you have to do start from a constant plus another constant times x, which is we have the same power right here, x to 1 times exponential. When s equal to 0, and then you think about this side, compare here and here. So the yc, there are no exponential term. So in this case, s equal to 0 is okay. This is the right way to do. For the second term, okay, second term and this term, x sine to x, and this is the polynomial x here. So let's start with b1 x plus b0 cos 2x x to the s. If s equal to 0, this term go to 0, right? This term go to 1, sorry, this term go to 1. So, but when you think about compare this and this one, we have b0 cos 2x and c1 cos 2x, which is the same solution. So in this case, s cannot be 0. It has to be a higher value, which is 1, x to the s equal to 1, okay, and s is equal to 1 here. And don't forget the sine term, cos and sine. So on this side is also the same. C1, another just say a constant. You can use like ABC or like C1, C2, C3. It doesn't matter. Okay, and C1 x plus C0, and also this time x here, x to the s equal to 1. And then you do the first derivative of yp, both yp1 and p2, and also y double prime of p1 and p2, then substitute into this y double prime plus 4y, and then compare the coefficient between these two to solve to get a1 a0, b1 b0, c1 c0, and then to get the yp, and so the final solution is going to be yc plus yp, which is the final answer. Okay, in this slide is in this video we will talk about the second ODE of the homogeneous equation and non-homogeneous equation. What I'm gonna focus here is the non-homogeneous equation. You have to use the undetermined coefficient method to solve the problem. So in the exams, we have some like one of these equations. So you have to you should be able you have to know how to solve it, and you should solve it. I mean you must solve it. Okay. These are the reference that I use some of these from these books to teach in this class. If you want to know, you can get exercise from all this to practice yourself and get ready for the mini exam. Okay, for the mini exams, it's gonna cover the first chapter and this video. Okay, and at the end of this video. Okay, hope you get luck. Good luck for the mini exams, and I'll see you in the class.